All right, welcome folks. My name is Brian Hess. I'm a solution architect specialist focusing in Amazon DocumentDB. We're going to talk a bit today about transactions. So this is a feature that we added to DocumentDB back in the fall. So I wanted to talk through this exciting new feature and the pieces that you can use to in your applications. But what I wanted to start with first, in case some folks are less familiar with DocumentDB, is just a really high-level overview of DocumentDB. There's some really good deeper dives, or we have a couple of reInvent sessions that would be interesting if you were interested in going a little deeper. But just want to cover the highlights so you sort of understand where we're coming from here. So Amazon DocumentDB is a fully managed, scalable document database. And we designed it to cover MongoDB workloads. And so what do we mean by that? So from the fully managed side, this is a cloud architected service that's managed for you. So we've taken care of all the undifferentiated heavy lifting. We've designed it with built-in high availability and automatic backups and point-in-time recovery. The data layer that we have architected is durable by default, so you don't have to do anything to ensure it's configured correctly to make sure that the data survives. That's just part of the way we've designed it. Similarly, security, so we're talking encryption at rest and encryption in motion, user privileges and roles and access permissions. All those security best practices exist by default in DocumentDB. And then, as I mentioned, it's a fully managed service. You don't have to take care of any of the patching of the operating system or the database software. We take care of all of that. Similar to other services in AWS, we also have pretty rich environment for monitoring the DocumentDB cluster. So use CloudWatch is the way that we visualize and give access to those monitoring tools. And you can also set alerts. So you could set alerts there if all of a sudden there was an increase in workload that you weren't expecting, and that makes you want to expand or modify your cluster with response to that. So that's what we sort of get at from fully managed. In terms of scalability, DocumentDB was designed in the cloud for the cloud. So scalability is a key part of the design principles there. The ability to scale up and scale out in minutes just by going through a couple of either API calls or using our console. The storage, I mentioned the storage layer on the previous slide as being durable by default. It also scales automatically. So you don't have to do anything to provision extra space. You just start putting more data in, and we will, under the covers, expand that storage as needed. And of course, the access I/O to that storage. Scales all the way up to 64 terabytes, which is quite large, actually. You can configure, well, DocumentDB is set up to look a lot like MongoDB replica sets, if you're familiar with MongoDB. And in that world, in that configuration, there's one writer instance, and you can have many reader instances. So those reader instances can take over for the writer in the case that the writer has some sort of a failure, but they can also be used to increase read traffic. So if you have other read workload you want to add to the cluster, you can add extra read replicas, and they just take a few minutes to add those instances to the cluster. The architecture is set up in such a way that in order for those read replicas to start serving read requests, no data needs to be moved around to them because we've separated that storage layer from the compute layer. And so we get this sort of scalability built right on in from the start. And then lastly, MongoDB compatibility, it's part of the service name, the full name being Amazon DocumentDB with MongoDB compatibility. And we designed it so that drivers and applications and tools can be used with DocumentDB just like they could be used with MongoDB. Now, we don't have the full coverage of the MongoDB API. We have really focused on the ones that our customers have told us are the most important. And so we're always working backwards from what our customers need and we add to those APIs and the operators and the stages in response to working backward from customers. And that's exactly sort of how we got to transactions. So transactions was something that we had heard from customers as being something really important to their applications. And so we were able to add that, like I said, last fall to the mix. So if we talk about what we'll talk about today, I wanted to give a little bit of an understanding of why are transactions even an interesting thing to talk about, like why were customers telling us that they would like them added to the API, a couple of transaction use cases, and then dive a little bit into what do transactions look like in DocumentDB. If you're familiar with transactions in MongoDB, you'll see a lot of similarities here. But they're a little bit different sometimes than some relational systems that you might be familiar with. And so it's good to call out just exactly what do these transactions look like in DocumentDB. And then we'll have some examples as we go through that. So let's start with why transactions. And I think that you sort of understand where this comes from. We sort of hop in the Wayback Machine and go back to the sort of relational world. So relational databases popularized, several decades ago, really. And one of the core tenets of a relational data model is to normalize the data. And so what you do when you do that is you take redundant or repeated information and you put it in its own table, and then you give a link from between the tables so you know how to get to that information and understand that relationship. So for example, if we had a business directory or something like a Yelp where we've got businesses and they've got addresses or they have owners, you may end up with multiple businesses, say, at the same address. And so we could take that address and put it in its own table and have a link from the profile for that business to the address entry in its own table. Then if we needed to update something about that address, I don't know, if there's a fire lane out front or if there's sprinklers in the place, we can update that address and the information about that address once for all the businesses that are in that same place. So we get this nice way of operating with things where we can separate out the pieces so we don't need to make many updates and keep things in sync. But one of the challenges with that is there still ends up being use cases where you need to update the information in multiple tables at the same time. And so we might want, or just multiple records within the table at the same time. And so we now need to sort of keep things in sync. We want to make sure that nobody is seeing some weird partial view of the world. They're seeing those changes kind of come as an atomic unit. There's the possibility of something going wrong in the middle so that if something were to happen while I was making those changes, they'd kind of get backed out. So nobody is seeing partially committed changes to the mix. So we end up with this transactional need based on the transactional model. We have this need for transactions. And so that's really kind of where the concept got popularized because it became a key part of relational models. So why are we talking about that if we're talking about document databases? So document databases, similar to other NoSQL systems, really leverage denormalizing the data. So we can see here kind of this example of that Yelp-like use case where we've got a business and other information, and we're keeping that information with the business as an embedded part of it. So we see here that the location is a subfield. It's kind of its own little record within a record inside of the business record here. And the idea is that if you're asking for that business record, you're very likely to want the address. So why don't we co-locate this information or denormalize it so that you can get it right away when you go get that record? It's probably what you're about to ask for anyway. Denormalization also used in the relational world, usually more in like data warehousing, but you definitely see it in the SQL world as well. And in those cases, it's also there to increase performance. So we have this denormalized data model. So some of these updates that I was saying previously was to update in multiple tables. They would now be multiple fields within the same document. And we already have that. So DocumentDB's 3.6 engine, when we launched DocumentDB, a little over 2 years ago was this 3.6 compatible engine, and that already supported updating multiple fields in the same document as one just atomic unit, all or nothing, et cetera. So we already have that. We have that also in the 4.0 engine, which came out in the fall as well. So that's already there. But if you go through the document modeling, data modeling sort of best practices, there are some times when you do want normalization. And you do want to sort of talk about how these things should be split up into multiple collections. And so we're back to wanting to do those updates across multiple collections. There's other situations where you want to update multiple documents within the same collection, and you want those to be in sync as well. And we'll talk about that, some of those use cases on the next slide. But it's important here to say, like, we've introduced this new tool, this transactions tool, which can be a bit of a crutch in some situations. The document data modeling best practices still apply. So don't go crazy with transactions now just because there's a new toy in the toolbox. We still want to do the best practices for data modeling so you can get the best out of your document database. We don't want to necessarily just take a relational model and move it over. That's not the best way to get all the power of DocumentDB, which is also, for what it's worth, the same as people say about MongoDB. So the similarities exist there as well. So let's talk about a couple of use cases. Probably the first, like, easiest use case for transactions is probably this ledger use case, top right. They're kind of financial transactions. And the idea is that you've got maybe a balance type data set. So this collection is the balance for individual users. And if we're going to decrement Brian and give data over, or give money over to Phil, then we want to decrement Brian's account and we want to increment Phil's account. But we really want that to sort of happen as one thing. We don't want to take money away from Brian and then something go wrong and now all of a sudden some money has disappeared from the system. We want and similarly the other way around. We don't want to give it to Phil and then something go wrong and we never finish and now all of a sudden money appeared out of nowhere. We want these to happen together. Take money away from Brian, give it to Phil, and the world sees that whole thing as one operation that's just happened at the same time. The many-to-many relationships one is one where we start talking about multiple documents. So for instance, we could do something like room reservation, where we want to know things like if a guest has a guest profile, we want to see all the reservations that guest has made. And similarly, we might have a rooms collection so that we can take a look from the room side which reservations were made by which guests. So if you go to reserve a room, we update both the guest's profile to tell him that he's now reserved a certain room on a certain day, and we update the room profile to indicate that we've got a reservation by a particular guest on a particular day. So we need to get those two things to happen at the same time. We wouldn't want that information to get out of sync. There are some times where you want to do an operation and log that it happened. And so you might be really trying to keep a strict sort of auditing capability that you manage in your application. And the idea is that you don't want to do an operation unless you can also log it. You need to make sure that both happen. You don't want to have operations that happened but weren't logged, and you wouldn't want to have things in the log that never actually occurred. So you sort of want those two things to come together if they happen at all. And then last, there are some situations where when you do a real world business operation, you need to update multiple collections. So like, for instance, if I'm going to create an account, I might need to create a document for that new user or that new account in multiple different collections because of the way that we manage our data. And so we would want to make sure that we got all of them taken care of, and that when the account creation happened, we successfully wrote that new record or that setup into each of the collections. So sort of from a high level, a few motivating examples you'll see as we get into the characteristics, sort of how these use cases and their needs kind of come into what those characteristics look like. So before we get into the details of the actual, characteristics and dive into what they look like, figured we'd do a really quick example just to see what the API looks like. So this is Python. The concept here is that it should be pretty simple. And so what we see is we're going to create this session. So a session is what we will start our transaction on, at least in the Python world. It kind of operates this way. So the first thing is we create a new session called S. And then what we're going to do is start a transaction. So we just say s.start transaction. Now we're going to try two things. So we do this try and catch block just in case there's an error. We'll talk a little bit about the types of errors that you can occur. But just in case there's an error, we want to be able to handle that appropriately. So the try block is going to try to write doc1 into the first collection, and we'll write doc2 into the second collection. If everything goes well, then we jump down to the bottom and we commit the transaction. So nothing really has been permanently saved in the database in a way that other users can see until we commit the transaction. So we just do s.commit. That's going to say anything that was done in this transaction should now be committed to the database, and everybody should see it. If something does go wrong, we're going to catch that exception, and we're going to abort. So the abort transaction is really a way of saying, forget everything I just tried to do. Please put it back the way it was and pretend I was never here. And so none of the partial writes, like for instance, if the first operation worked and we actually got doc1 into the first collection, if we had an error on doc2 writing to the second collection and we choose to abort, we're going to pretend like, hey, just don't do that write to the first collection. Just back the whole thing out and make it as if I had never done anything. So that's the sort of abort transaction piece. And then raise, we're just going to raise the exception up to the calling function so that he can handle whatever else he wants to do with this. We'll talk a little bit more at length about how to actually handle exceptions and retrying things in a moment, but just wanted to give this idea of pretty simple. You've got this session, you start the transaction on the session. Well, I didn't say this, but when you do the write operations, an insert, an update, a delete, you want to make sure that you pass on in this session. You can actually do a query that's not part of the session. We'll talk a little bit about how writes that happen or that are not part of the session and what their world looks like, how things are a little different. But if we want it to be part of the session, we have to pass on in that session object. So the insert one method takes an additional optional argument of a session, which will tell the database that this is part of the same transaction. So that's a really important part that says session equals S there. Okay, so let's move on to the characteristics. So what are these things? What do they do? What do they feel like? What promises are being made here? So the first thing to understand, we talked about how single document, like multiple fields in the same document, those sorts of operations have already been essentially transactional, right? We can update multiple fields in a single document in an atomic way that just all or nothing, and it gets done, and people see it as all those updates happen at the same time. These transactions, these new transactions, really are multi-document. Those documents can be in the same collection, kind of like that ledger use case. They can be across different collections. They can even be different collections in different databases. Those update operations typically are also multi-statement, so it's multi-everything. One of the key features of transactions is really this all or nothing capability, and I kind of hinted at that before. You're going to do a number of write operations, inserts, updates, or deletes, and either all of those writes will occur and be reflected in the database when we're finished, or none of them will. So all of them are if we commit the transaction, and none of them are if we abort the transaction. So we really have this sort of, no one is able to see what's going on while we're doing our transaction. They just see as if everything happened at the end. Snapshot, or isolation in general, but snapshot isolation is an important part also. And this is really in two places or two ways. The first is for my transaction, when I begin a transaction, it's as if I'm freezing the whole world for me right now. So everything that I'm going to do with the data is going to be looking just like the data was when I created my transaction. So any updates that are happening by other users, by other applications, by other connections, I'm not going to see them in my transaction context. Right? So it's nice and simple. That way I can work on data and know that it's not changing underneath me. I have a nice little isolated view of the world. So only the writes and the updates that happened before I started my transaction are going to be visible. You know, the other side of the isolation is that with all of those writes and everything, no one's going to see any of my partial work until I commit that transaction. So I have this little isolated world. The data is not changing from underneath me, and then no one's seeing anything I'm doing while I go until I commit. And the last part is this idea that, well, no one else can see my writes and my partial work while I'm going, but I can. And that's an important part. So I can do in my transaction a combination of reads and writes. So I might do a read, figure out a couple of writes to do some more reading, do some more writing, and back and forth. When I go and read from the database, I'll be able to see all of the writes that I did, even if they haven't been committed yet, right? So I'm in my little world, in my little bubble. And so I get to see the database as if all of the things that I was writing had been committed. Now, they're not actually going to be visible to anybody else until I do commit, but this allows for my world to stay consistent. So if I do a write, I then immediately do a read, I can actually see that write reflected within my transaction. So let's ground this in a couple of examples. So let's imagine we've got our business profile here on the right, and my transaction is just simply going to be, I want to update the review count from 46 to 47. So if I then want to go ahead and read within my transaction, I'll see that the value is 47. If I have a regular read go at the same time and try to read the review count from this record, before my transaction has been committed, it will see the old value as 46. So I'm still seeing the old value because my transaction hasn't been committed yet. So let's go ahead and commit that transaction. And now when a regular read comes on in, it'll see that value of 47. So we all of a sudden it's revealed. Okay, so pretty straightforward with respect to reading your own writes and the isolation, the all or nothing kind of capabilities here. Now, there's one more aspect that we want to talk about, and that has to do with write locking. There are a couple of different ways to handle concurrency in general with database systems. One of them is to do write locking, and another one is what actually DocumentDB uses or used prior to transactions and still uses for regular operations, is something called multi-version concurrency control. And this is a way that you can go ahead and have multiple users writing and reading to the database without having to lock records when they're being read or when they're being written, and it allows for a lot of multiple users querying at the same time. However, with transactions, because we're trying to do a number of things all at once, we do introduce write locking. And we're only going to lock the records that we needed to write. So if you do a write to a particular document, the database will put a little lock on it. And that's not really a problem. If people read the rest of the documents that are out there, no worries, everything is fine. If another transaction wants to update the exact same fields, the exact same documents as the first transaction, then it'll get an error. That transaction will get rolled back. The whole transaction, not just that one little operation. Now we'll talk a little bit about how we want to handle if and when those errors occur. But if you stumble into something in your transaction that somebody else is changing in their transaction, we're going to run into an error that we abort. If on the other hand, somebody does a regular read on that updated record. So if we go back to the scenarios where we're doing a regular read, so that's not within a transaction, that will actually block. So it's going to encounter that a write is happening within a transaction, and the write will just wait. So there's no error. It'll just wait until that transaction is completed, and then it will be able to read that record. Just something to note, there is still a write timeout in these operations. In DocumentDB and in MongoDB, we have this query timeout that happens here. And so if your read is going for a very long period of time, it will eventually time out. So if that transaction blocks for too long, some of those reads will get timeouts. So those are for writes. Reads inside of a transaction don't lock the document. So if you want to go ahead and do a read, that's fine. Go for it. You're not impacting anybody else. There are some times that people will want to do some locking for various reasons, even when they do a read. And if you find yourself in that sort of rare case, you can do kind of a dummy no-op operation. So you can do something that doesn't really matter to the business. So this example here, we're incrementing a dummy counter. Like, we're never really going to use that dummy counter field. All we've done here is update it so that that we do end up creating that write lock. Like I said, it doesn't come up all that often, but sometimes people do want that. And that will then obviously force the lock, and then you kind of have the behavior you were looking for. But reads in general don't lock the document. I mentioned that regular writes will block while the transaction's happening. So will DDL. So if there is a DDL operation happening outside the transaction, it's going to look at the table and see, or the collection, and see that some of the documents have been locked, and it's going to wait. And so that DDL could be something like creating an index or something along those lines. So those operations will wait, just like the write operations in outside of the transaction. I do want to call one note here. This is the one big difference between MongoDB transactions and DocumentDB transactions. And that's that in MongoDB, there was an optimization that they took where if you do a write to a document that would result in nothing changing, then it doesn't actually lock the document. It recognizes this like, hey, that wasn't actually going to change anything. So for example, before I was changing that review count from 46 to 47, if instead you actually set it to 46, MongoDB will recognize that and say, that actually won't change anything because the current value already is 46. I'm not going to lock the record. DocumentDB locks the record regardless. So it's not going to actually try to go in special case, did this change really matter? You know that if you do a write, it'll always lock. And I think that's actually a little bit better from an application development standpoint of understanding what's going to happen in your database. I like the fact that if you do a write, it will actually lock that record in a transaction. You don't have to worry about, well, what was the state beforehand? And so I think from an application development standpoint, it might be a little bit more locking going on in DocumentDB, but you kind of understand what your operations do with respect to whether or not things will get locked. So let's take a quick look at an example. So we've got our same sort of data model here that we've been talking about. In transaction number 1, we're going to go ahead and update that 47. What you'll see sort of that kind of circle with the slash is supposed to represent that there's now a lock on this record. Transaction is still going on. So now transaction 2 comes along. It wants to update maybe something different in that field, like the price to $2 signs. It will encounter that there was this lock on there, and it will actually roll back all of transaction number 2. So it hits a wall and then unrolls itself back so that the transaction is rolled back. There you go. However, if we do a regular write, so here we're back to just doing an update to maybe this way, we're doing it outside the transaction to update to $2. It's just going to wait. That's what I meant by this sort of yield sign here. Once transaction 1 gets committed, then the regular operation will get sent through, and you'll see we now update the price from $1 sign to $2 signs. Okay, so regular operations will wait. If for whatever reason transaction 1 was taking a really long time, then eventually that regular operation would time out. All right, so we talked about the types of errors that can happen. What should we do about retrying them? So there are 2 kinds of errors I want to talk about when we do these transaction operations. We can run into an operation failure. So it's an error thrown by the server. The MongoDB API introduced this concept of adding a tag to the error. And the tag tells us a little bit more information about what's going on. So if we encounter a write lock in our transaction, so somebody else was already updating this particular document, so we're going to get that rollback scenario, we will get an operation failure error that will include this transient transaction error tag. That's going to be our notification that that we encountered that situation. Now, the transient in there is important. It's telling us, actually, I couldn't do this because somebody else was in the middle of a transaction, but that shouldn't stop you from trying again, because once that transaction is over, I'd be happy to do that operation for you. So you can retry the whole transaction if you bump into a transient transaction error. So that's the first kind of error. The second kind of error is one where on the way, when you try to commit the transaction, you might run into an error from the server. And the problem with that error when you do a commit is you don't know if the error was on the way of communicating that to the server to tell it that it should commit, or if it was on the response back from the server telling you that it actually did commit. So you don't know whether or not you actually got the commit result you were looking for. And that's why the tag is unknown transaction commit result. So these can happen when you try to commit. Unfortunately, in DocumentDB, this is slightly different than MongoDB. We can't retry the commit on its own. So we wouldn't do that. We'd have to figure out how we wanted to approach that from the application standpoint and handle that in its special case, because if the operation did commit and we were getting the error, we need to detect that situation in a slightly different way. So if you get, so the other thing to note is that when the unknown transaction commit result tag is present, so for some reason is the transient transaction error tag. So what we're going to kind of look for is we want to see that it has the transient transaction error tag, but it doesn't have this commit error tag. And then we can retry those whole operations. So let me ground that in some code. So here's a silly little example, again, very much like the one that we started with way back at the beginning. And what we see is this first function at the top called run transaction, which will start a session, start a transaction on that session, do the same to inserts, and then commit, okay? So we're not going to do that in a try block. We'll do that in a try block in this sort of function 2. So function 2 will come on in, it'll try to run the transaction. If everything works great, then we return the result and we're good to go, and the function 2 finishes. If there is some kind of an error, we're going to catch that error. We're catching these operation failure and connection failure, and we're going to look to see if the transient transaction error tag is present or label is present. We're also going to check that the unknown transaction commit result is not present. So we're in that situation where we encountered a write lock. So we'll just do a little print, and then we'll continue, and the continue will send us back around this while true loop. So this isn't necessarily the best practice on how to handle all the retries. We can get much more fancy logic, like we could do some exponential backoff, so we're not just pounding on the server and we keep trying over and over again. We might add small delays in there. We could add a counter that says only retry this 2 or 3 times. Just to keep the brevity of this slide, I took that very basic idea of putting it into an infinite loop. We're just going to keep trying this transaction until it succeeds. There's obviously issues with that, like if it doesn't succeed after a while, you probably should give up. Otherwise, you're wasting resources. So you could feel free to take all sorts of variations on this code. I'm just using it here for just explanatory purposes. All right, so let's talk a little bit about the similarities with MongoDB. So if you're familiar with MongoDB transactions, what's the same? And the answer is an awful lot is the same. So reads inside of a transaction do not lock the document. That's the same as MongoDB. Writes, so if I do a write and it does a lock, writes in another transaction, if they encounter a document that I've locked, will roll back, same as MongoDB. Regular writes outside of a transaction will just wait, so they'll be blocked behind that transaction, and once that transaction completes, then the regular write will be allowed to finish. Similarly, DDL will happen, will also block while that transaction is happening. The transactions in DocumentDB are very similar to the way transactions were in MongoDB 4.0. And that covers sort of the next 2 bullet points. Later on, in later versions of MongoDB, some of these 2 points change, but currently DocumentDB does not allow for a DDL operation inside of a transaction, which is the same as it was in MongoDB 4.0. And similarly, the maximum transaction size is 16 megabytes. Again, same as MongoDB 4.0. And then when you encounter this transient transaction error, which sort of indicates that you've hit a write lock contention, you should retry those errors or retry those transactions in their entirety. There are a couple of differences. We've talked about them already, but I'll reiterate them here. The first is if you do an operation, a write operation in DocumentDB, regardless of whether or not that update changed anything, you will lock that document. So MongoDB has that no-op detection, and in which case it won't lock the document, but DocumentDB will do a lock regardless of whether or not the change made a difference or not. And we talked a little also about you can't retry commits if you see commit errors from the database. So that's just a slightly different best practice in terms of error handling with DocumentDB. Did want to call out 2 things to note. It's not so much a difference from MongoDB. This is just more on the you should know about. The first one is that there is a time limit on a transaction that's set at a minute, and that sort of protects the server from transactions that just stay for a very long time and could potentially keep these locks for a very long time. So there is a transaction timeout of 1 minute. And then this sounds a little silly, but you can only do transactions on the primary. The primary is the only one that's allowed to do writes anyway. And since transactions really are largely about writes, this isn't too much of a surprise. But I did want to sort of just put it out there that if you're going to do this, do transactions, you're going to want to set your preferences to the primary. And then just kind of summarizing up about transactions. First thing, I'd be remiss without reiterating that the document data modeling best practices still apply. You should still go through and do all the best things that we've been talking about. Even though we have this new tool, it shouldn't drastically change the way we approach data modeling. And so, for instance, if you find yourself with transactions being kind of your dominant way of doing reads and writes to the database, especially writes to the database, it's probably a flag that we should take a step back and think about how we're doing this. But transactions are an important tool in the toolbox, so we should use them appropriately. Whenever you're doing an operation that you want in a transaction, please make sure to pass the session along with the statement. I'm speaking from personal experience of having goofed this up a few times, but that extra parameter that says this is part of a transaction or part of a session is important to remember. We talked about this bullet on handling errors applies really in general, but it's worth reiterating with respect to transactions since we talked about it. Handle the errors that we see, retry the ones that you can, and do all that appropriately. And then just keeping an eye on if you did mean to lock a record, like if you wanted to do a read, make sure you do a write, and that will cause the system to lock that record. And with that pretty much covers transactions in DocumentDB 4.0. Really exciting new feature added in the fall, and really look forward to seeing what everybody does with the new tool in the toolbox. So thanks.